We are going to see how an image histogram is getting created. An image histogram is a graphical representation of the distribution of the pixels in the image. So let us see one simple example. So basically we count how many times does each pixel appear, and then that gets plotted on the histogram. So consider if we have a 3-bit grayscale image, where 3-bit grayscales means it can have 2 power 3, 8 values ranging from 0 to 7. So let us consider that this is how the image is, and these are the frequencies. 4 appears 3 times, so hence 4 appears 3 times. 2 appears 1 times, yes, 2 appear 1 time, 2 appears 1 time. So like this I am getting a histogram. So this is basically the idea of a histogram. So in a digital photograph also we do it on the same way, but just that on the x-axis I will have 0 to 256, and on the y-axis it will have many pixels. So on if the right side is bright, if the right side is more, that means there are more of bright areas. If in the center it is there are many it's a highlight, that means it has more of median tones. And if in the left half if it has more of pixels, that indicates a lot of shadows. For RGB channel also we do the same way, just that every time we see or red, green and blue, 3 different histograms will be maintained, and similarly the values are getting calculated. We also have one more concept which is called as the average optical density. Now average optical density helps to measure the image overall average brightness. So either we can calculate it from the image, or otherwise we can do it easily from the image histogram. So image histograms helps us to do even that. Consider if I have this image and I calculate, if I compute directly from the pixels, then I have to add up all individual pixels and divide it by the number of pixels. So in this case I am getting 2.67. This is one way to do it. The other way to do it is from the histogram I calculate, like we had 4 appears 3 times, 2 appears 1 times, 1 appeared 3 times, and so on. I calculate all this, add up all, and then I can divide by the number of pixels. So this process makes it easier to calculate average optical density. Consider if I have a lot many pixels, like for example 12 megapixel image. So direct method will take longer time, but if I follow histogram method, it will be faster. So histogram help to compute average optical density, and it also helps to understand the auto exposure, instant enhancement, any kind of power saving that needs to be done, or if a fast staining of the images needs to be done, histograms are being used. So this is one example of a histogram. See, as you can see here, this is a darker image, and so you are seeing more on the left. This is a correctly exposed image, so these more of midtones here, and this is a brighter image, so I'm seeing a lot of brighter values here.